Hello everyone. My name is Sanya Sige. I'm a student of 3rd SEM CSC studying in Sri Venkateswara College of Engineering. And my topic is analysis of completely randomized design and randomized log design. So let's begin. First, we have unraveling experimental designs, CRD and RBD. This presentation delves into the world of experimental designs, focusing on two common methods: completely randomized design, CRD, and randomized block design, RBD. We'll explore the definitions, advantages, litiges, and practical applications. Next, let us look into the introduction to experimental designs. Experimental designs is a structured approach to conduct research, systematically manipulating factors to observe the impact on a response variable. Next, understanding the world. The goal is to establish causal relationship between independent and dependent variables, minimizing bias and maximizing precision. Moving on to the next topic, completely randomized design, also known as CRD. CRD is a fundamental design where units are randomly assigned to treatments, ensuring no systematic bias in the allocation of treatments to subjects. Random assignment. Randomization is crucial to minimize the influence of confounding factors and achieve independent observations for analysis. Let us look at some of CRD's definition and assumptions. First, we have random assignment. CRD requires random allocation of units to treatment groups, minimizing bias and maximizing representativeness. Normal distribution. The data within each group should follow a normal distribution, allowing for accurate statistical analysis and interpretation. Next, independence. The observations within each treatment group must be independent of each other, ensuring that results are not influenced by any common factor. Homogeneity. The variance of the data within each group allows equal stable groups comparison and treatment groups. Next, we have advantages and limitations. CRD is simple to implement and analyze, requires less complex statistical procedures. Next, looking at limitations, CRD may be inefficient if there are significant variations within the experimental units, requiring a larger sample size for reliable results. Let us look at the ANOVA for CRD. Hypothesis testing. ANOVA tests for significant differences between treatment groups based on the variation within groups versus the variation between groups. F statistic. The F statistic measures the ratio of between group variability to within group variability. P-value. The p-value determines the statistical significance of the F statistic, indicating the probability of such differences by chance. Interpretation of results. Statistical significance. If the p-value is below predetermined threshold, for example 0.05, we reject the null hypothesis, concluding that there is significant difference between treatment groups. Next, practical implications. The interpretation of results considers the context of the experiment, including the magnitude of the differences and the potential implications for real-world applications. Next, we have randomized block design, also known as RBD, controlling variability. RBD is designed to control for variability within the experimental units by dividing them into homogeneous blocks based on a specific characteristic. Random assignment with blocks. Units are randomly assigned to units within each block, ensuring that variations within blocks are minimized. Increased precision. RBD is typically more precise than CRD when there is strong correlation between blocking factor and responsive variable. Next, we have some RBD's definition and assumptions. First, homogeneous block. RBD requires dividing units into blocks where units within each block are more similar than those between blocks. Next, we have random assignment with blocks. Within each block, treatments are randomly assigned to units, ensuring that variation within blocks are minimized. Normal distribution. Data within each treatment group should follow a normal distribution, allowing for valid statistical analysis and interpretation. Homogeneity. The variance of groups of treatment of groups equals allowing responsibility between them. To conclude our today's presentation, this presentation explored CRD and RBD, two fundamental experimental designs that are crucial for conducting robust research and drawing reliable conclusions. Understanding the strengths and limitations of each design is essential for selecting the most appropriate approach for your research questions. With careful planning and execution, experimental designs can provide valuable insights into the world around us. Thank you for watching.